बहुत लेट हो रहा है बेटा ज्वाइन करने में सभी लोग। मैसेज लेट पहुंचा, क्या हुआ? Okay, so what was our discussion in last session? Yes, quickly. Topologies. Okay, what else? How many topologies we were discussed? We discussed, I think, networks as well, LAN as well, networks as well, ring star inverse. Good, Ritika. Okay, so we can move from here, from the last session, the topology is clear. So ring, bus and star was the topology. Now today we will discuss the transmission media, all right, and transmission speed. So many things we are aware. So communication medium, the physical transmission medium, twisted pair wire. ट्विस्टेड इट्स लाइक एक दूसरे में जो गुथे हुए टाइप के रहते हैं, जैसे गर्ल्स को आप देखते होंगे चोटी जो बनाते हैं, ठीक? तो चोटी में क्या करते हैं, हेयर्स को वो 3 पार्ट 4 पार्ट जो भी जिनका रिक्वायरमेंट होता है डिवाइड कर लेते हैं, फिर उनको एक प्रॉपर ऑर्डर में एक दूसरे में ट्विस्ट कर देते हैं, है ना? तो ऐसे ही दो वायर नॉर्मल आपने देखे होंगे घर में, इलेक्ट्रिसिटी का वायर देखा होगा। दीपावली के टाइम पे हम सीरीज का यूज करते हैं लाइट्स का, उसमें देखा होगा कि जो वायर आता है वो ट्विस्टेड टाइप से रहता है। लेन का भी अगर आपने केबल देखा हो, लोकल एरिया नेटवर्क का जो लेन ईथरनेट केबल जो होता है, उसमें भी 4 सेट ऑफ वायर्स होते हैं, वो भी ट्विस्टेड रहते हैं 2 2 के पेयर्स में। I will show you in the coming slide. Then coaxial cable. This cable everyone is aware. I don't know whether you are aware about the name or not. Coaxial cable is the same which you are using in your television, the direct to home or a cable connection. आपके पास डायरेक्ट टू होम कनेक्शन हो घर पे या केबल कनेक्शन हो, either one, both way we use this particular cable. I will show you again the structure of it as well. And then fiber optics cable, OFC. ये चीज आपने, मुझे नहीं पता आपने देखा है कि नहीं देखा है। अगर आप यहाँ होते तो मैं वाकई आपको दिखाता भी, क्योंकि इसके एक्सपेरिमेंट्स हैं, फिजिक्स की लैब से अपने को मिल जाते हैं। तो मैं जनरली जब भी ये टॉपिक लेता हूँ तो बच्चों को दिखाता हूँ, क्योंकि हमने ऐसे फिजिकल सेंस में नहीं देखा होता है। I will show you the photograph in the coming slide. OFC, आपने you may have observation when you are going through the road, same like a milestones, जो नील के पत्थर रखे होते हैं, वैसे ही आपने कुछ और पत्थर देखे होंगे जिसपे लिखा शायद आपने देखा हो एयरटेल OFC, जियो या रिलायंस OFC, वोडाफोन OFC, BSNL OFC। जिन जिन के भी केबल जमीन के नीचे से गए हुए हैं उनका वो डिटेल वहां पे होता है। वायरलेस मीडियम्स तो इनमें से शायद एक तो हमें पता ही है, दोनों ही जहां तक मालूम है। एक तो अपना हो गया सेलुलर फोन, वी ऑल आर यूजिंग, दैट्स वायरलेस। Satellite भी, those who are using DTH connections, they are ultimately using that transmission, wireless transmission। अगर केबल कनेक्शन आ रहा है तो बात अलग है, अदरवाइज सैटेलाइट के ये हुए। इनमें से कोई चीज जो आपने देखी ना हो, OFC शायद फिजिकल ना देखी हो. Other than OFC, optical fiber cable. अगर सारे देखे हैं, if you have seen all of these, then please put your comment. Yes sir, I know, and I have, at least in a physical form, I have seen it. Anyone, those who have aware, or those who have seen the cellular mobile phone, or a direct to home, or a coaxial cable, the cable which you are using for direct to home, twisted wire, kabhi life mein dekhe? Have you ever seen those things?
Yes, sir.
Okay, only one person in the class who knows the twisted wire, or he is having the television set at home, and he is the only one who is using the mobile phone. None of you are using the mobile phone. You are not aware about the satellite medium, wireless medium. बहुत फुर्सत में बनाया है ईश्वर ने आप लोगों को भाई. 5-5, 7-7 मिनट लग जाते हैं ऐसे क्वेश्चंस के आंसर देने में. In next slide, I will show you the pictures related to it. Then transmission speed. So transmission speeds actually measured in these three forms. One is called bits per second, then to the hertz used for the frequency or the wavelength, and then the bandwidth. So the transmission capacity of a medium, that means bits per second, is actually depend on its frequency. Frequency, how frequently you are switching or sending. So you may have any observation in your LAN cable or hubs or switches available at Marwadi campus, that they have the blinking. ब्लिंकिंग देखा होगा, लाइट का जलना बुझना, छोटा सा एलईडी जैसा एक बल्ब होगा, वो बार बार जलते बुझते देखा होगा, बार बार repeatedly it's blinking, it's on off on off on off, that too in a very high frequency rate. So the light is depicting the, yes, you are sending the signal in the combination of 0 1. Clear? So the medium is measured through the bps, clear, or called bits per second. That bits per seconds depend on the frequency, and the frequency is measured in hertz. So your processor, you may be aware about, your processor is 1.6 gigahertz, 2.4 megahertz, 2.3 gigahertz. Even your mobile phone also, the chips, those who you are using it, I hope you, if you are aware a little bit about it, or you can see your own mobile phone specifications. Am I right? Through the settings, you can go and check what kind of a processor you have, what's the its speed, and so that's called as a measure in a hertz. That frequency measures in a hertz, how it's shifting or changing, or a cycle per second. Then bandwidth. Bandwidth, it actually it's accommodate on a single channel. So 5G bandwidth, waves अभी जो थी आपने देखा होगा 5G का waves auction हुआ इंडिया में. So it's like a capacity of the waves who can carry the particular amount of data. It's like you can understand in a physical form, like a auto, a three-wheelers, then four-wheelers, and then the truck. So three-wheelers are having limited capacity in terms of carrying the luggage or carrying the items in a kg kind of a form, kilograms, tons, or a metric ton. Obviously, the four-wheeler, the mini trucks may have the larger capacity than the three-wheelers truck, and then the actual truck, the bigger one, they may have the larger amount of capacity. Similarly, the waves. So waves are also having their own capacity, how much data they can carry. I hope, have you ever used the Wi-Fi in your mobile, or have you ever used hotspot with your other friends through your mobile? Yes. So that depend on what's protocol or what wavelength you are using in this Wi-Fi. So it will have its own speed. I hope you may be aware about the like USB 2.0, 3.0, 3.5, 4, and even 5.0. These 2, 3, 4 are depicting actually the generation or specifically the speed, how much data you can transmit or transfer. That's depend on that particular the USB type of a technology or the hardware software combinations you are using. So bits per second, then it's on the frequency form, so in a hertz, how, and then the bandwidth, the channel, the waves which through which you will transfer. Now see the twisted wire. This twisting is called, they are twisted, they are together moving with one to the other one, overlapping to each other. That's called the twisted wire. So this twisted, if you are using the single one, that's actually the LAN cable. So this format is a twisted form, right? So in this you will find the speed is somewhere limited, capacity is quite low. So in a LAN cable, instead of 2, we use 4 different twisted combinations. So it will become 8 and it enhance the speed. Then the next one is the coaxial cable. I don't know how many of you have seen it. In the coaxial cable, you will find the 4 different layers. So one is the inner one is the copper wire here, which is carrying the signal. Then you will find the thick insulator, so plastic, movable plastic, that to a thick one, motor, clear. So it will restrict the signals or a copper wire signals to be with this only, to be with this only. जैसे आप देखा होगा the light of a torch and light of a bulb in a room. So if you are using the bulb in a room, it will spread in the room itself. But when you are using the torch or a vehicle's light, it will have the direction as well. It will go long because now you are focusing the whole light into in one direction. So the length of the light will go very high. Torch use किए होंगे. I hope you will have used the torch. I am not saying about the mobile flashlight. That flash is different and that torch is different. That is only a bulb kind of a thing. But the torch you may have aware about the doctors use or we use in emergency. Only one person is understanding my discussion. Thank you, Dane. Then after this insulator, you will have another copper wire mesh. Mesh, it's called it's like a net. Clear? A rotated combined wire. Rotated one. It's a layer one, entire layer. It's having the capacity not to mingle the signals in one another. That's why the insulator is insulating the signals that's within this line only. and then you are having this copper wire, then another layer, the outer layer or insulation is what the plastic or any other material which we observe in a outside of a wire. I hope you have seen any wire in your house which is having the plastic coating, or even your mobile charger wire, laptop charger wire, headphones are also having one coatation outside insulator. Inside you will find the wire, but outside it's showing certain coating, so that will restrict the data, signals, electricity, all those things in a inside in a particular restricted manner. So that's called coaxial cable. The difference is that in twisted bare wire, speed was less, the data you can communicate was less, whereas in a coaxial cable the speed is very high, multiple data at the same time you can access. Like when you are using the DTH, let's say you are using the HD, full HD kind of a connection, and then you are having the connection with satellite. So immediately you will receive a good volume, good amount of data, that too in a real time live manner. You just imagine when you play something on your mobile, what will happen? When you play something on your mobile, then you will observe that if it is a high quality data, then your speed will become very low, or it may stuck in between. But when you are watching the same thing, high speed, high definition, videos, still they never stuck anywhere. टेलीविजन पे आपने देखा होगा ना, हार्डली कभी देखा होगा कि टेलीविजन का स्क्रीनिंग जो है वो स्टक हो गया क्योंकि डेटा बहुत हो गया था। या कभी आप 24 घंटे फुल एचडी पर अपने मोबाइल पे नेट चला के देखिए, फिर आएगा समझ में आपको कि हाउ मच डेटा यू रिक्वायर्ड टू वॉच अ फुल क्रिकेट मैच इन अ फुल एचडी मैनर. So this cable carries a good amount of data with high speed. Next one is the fiber optics. It's way beyond our imagination. It speeds like a lightning speed. Like sun is having the crores of kilometer distance from Earth, but the signal or the light from sun we receive within a 7 minutes. Crores of kilometers, and within a 7 minutes you will receive the light. Just imagine you need to communicate only on a earth surface. So what will be the speed? It's a blinking of your eyes, the signal will reach to the other end. That too, high volume of data with high capacity. India is the world largest country who is having under the sea fiber optics cable line. Those who are connecting globally, entire world they are connected. So its speed will become very high. And are you observing here it's the illuminators at the core end way. So somebody is putting light from the other end, and immediately as soon you will put, whether you are putting it into a round manner, that means this wire is rounded, twisted, it's coming from the various places, floors, whatever it may be. On the other end, even it's a lakhs of kilometers away, as soon they will send the signal, immediately it will start blinking here, although it is covering crores of kilometer distance. But there will be no difference of time. You can say immediately it will receive at the other end. And through the different coding, you can have a n number of connections in a single wire. This is the bunch of wires. You can select even a single wire, and thousands of connections you can carry at the same time, and all will have their own codings, uniqueness. Now we will see one video in which we will observe how a one simple communication through a mobile, how exactly it's reached to the other end, what are the parties or the things involved into it. Just watch this video.
Or any other information from any corner of the world within a blink of an eye? This has been made possible by a network of cables, which are laid under the ground and below the ocean. The cables, which carry most of the world's data, are optical fiber cables. They are also used in medical equipment. Let's learn how optical fiber cables work and how they have revolutionized the world around us. Optical fiber cable is made up of thousands of fiber strands, and a single fiber strand is as thin as a human hair. Optical fibers carry information in the form of light. Let's first learn some fundamental behaviors of light to understand the workings of optical fibers. The speed of light changes when it passes through a medium, and this change in speed is expressed by the refractive index. This variation in the speed of the light leads to another interesting phenomenon: refraction. To understand what it is, let us carry out an interesting experiment. In this experiment, light passes through a prism. You can see that at the interface, the light gets bent instead of going straight. This phenomenon is known as refraction. Refraction occurs when light passes from a medium with one refractive index to one with another refractive index. The light bends towards the interface when it goes from a medium of high to one of low refractive indices. Refraction is the reason why a pencil looks bent in a glass of water. This simple refraction technique is effectively used in optical fibers. Now, let's make this experiment a hypothetical one. Using some dopants, we are able to increase the refractive index of the glass in real time. As we increase the refractive index, the light will bend more and more towards the surface. After a time, you can see that the light will pass through the surface of the glass. If we increase the refractive index further, the light will suddenly come back to the first medium as a pure reflection. This is called total internal reflection. The total internal reflection is possible if we increase the incident angle rather than increasing the refractive index. In this case, at a certain angle called the critical angle, the light will come back to the first medium. This phenomenon of total internal reflection is used in optical fiber cables to transmit the light. The simplest form of optical fiber cable is shown here: cylindrical glass with a high refractive index. If the laser strikes the interface at an angle greater than the critical angle, total internal reflection will happen, and the light will reach the other end. This means that light can be confined in the optical fiber over a long distance, no matter what complex shape the fiber forms. Remember, total internal reflection happens between the high refractive index glass and the low refractive index air. However, optical fibers need a protective coating. A protective coating is not possible with this configuration. The introduction of protective material will replace the position of the air and cease the total internal reflection phenomenon. An easy way to overcome this issue is to introduce a low refractive index glass above the core glass, known as cladding. This way, total internal reflection will happen, and we'll be able to use a protective layer. Both the core and the cladding use silica as their base material. The difference in the refractive index can be achieved by adding different types of dopants. The optical fiber we have just constructed won't be able to carry signals for more than 100 kilometers. This is due to various losses that happen in the cable. This loss of signal strength is generally called attenuation. Absorption and scattering are the main reasons for signal attenuation. This is why you see amplifiers in cables after a certain distance. They boost the signal strength and allow signals to be transmitted over a long distance. The power required for the amplifier is drawn from nearby sources. Now, back to the main topic. How does the optical fiber transmit information such as phone calls or internet signals? Any information can be represented in the form of zeros and ones. Assume you want to send a hello text message through your mobile. First, this word will be converted into an equivalent binary code as a sequence of zeros and ones. After the conversion, your mobile phone will transmit these zeros and ones in the form of electromagnetic waves. One is transmitted as a high frequency and 0 as low frequency wave. Your local cell tower picks up these electromagnetic waves. At the tower, if the electromagnetic wave is of high frequency, a light pulse is generated. Otherwise, no pulse is generated. Now, these light pulses can easily be transmitted through optical fiber cables. The light pulses which carry the information have to travel through a complicated network of cables to reach their destination. For this purpose, the entire globe is covered with optical fiber cables. These cables are laid under the ground and below the ocean. It is mainly the mobile service providers that maintain these underground cables. AT&T, Orange, and Verizon are some of the few global players who own and maintain the submarine cable network. A detailed cross-section view of an undersea cable is shown here. You can see that only a small portion of the cable is used for holding the optical fiber. The remaining area of the cable is a mechanical structure for protection and strength. Now, the question is, where does the amplifier get power from under these deep oceans? Well, for this, a thin copper shell is used inside the cable, which carries electric power along the cable so that the amplifiers can be powered. This whole discussion simply means that if optical fiber cables do not reach a part of the globe, that part will be isolated from the internet or mobile communications. If we compare optical fiber cable to traditional copper cable, the optical fiber cable is superior in almost every way. Fiber optic cables provide larger bandwidth and transmit data at much higher speeds than copper cables. This is because the speed of light is always greater than the speed of electrons. The flow of electrons in a copper cable generates a magnetic field, even outside of the cable, that can cause electromagnetic interference. On the other hand, the light, which travels through the optical cable, is always confined within the fiber. Thus, the chance of interaction with an external signal does not exist. One more interesting feature about optical fiber cables is that any light signal which enters from the side has a minimal chance of traveling along the cable. Thus, the optical fiber cables provide high data security. You might be amazed to know that optical fiber was first used in endoscopy, even before it was used in the telecommunications field. In telecommunications, digital pulses are transferred through the optical fiber cable. However, in endoscopic cables, visual signals, which are in the analog form, are transmitted to the other end. We request your support at patreon.com to help us continue our education services. And thank you for watching the video.
Yes. Let me know if it is understood.
Yes, sir, it's clear.
Does it give any idea about how the transmissions are happening?
Yes, sir.
Even you can feel it on a real-time basis. Right now, we are also communicating through the same type of platform. Even including the different combination. I am on laptop through my mobile internet connection. You may be using on your mobile itself, or maybe your desktop. Somebody may be in laptop, right, with different kind of operators. Right now it's displaying the sonography machines. I hope you may be aware about. One more is called endoscopy. They also use the same lights cable to scan. That's having so many variations, so many applications as well. So quickly confirm whether this level of, because we are having only introductory level, the understanding, all three types of wires and the capacities. And this particular slides help us to understand how OFC, optical fiber cables, is capable to carry a huge volume of data. So shall we move?
Yes, sir, you can.
Thank you. Now, this is another term where I will take your help, because I don't think so anybody in the session right now who don't understand this term. Anyone? I hope everybody is understanding this term. So what exactly it is? Who is going to answer it? Try. Yes, please. You may be wrong. Nothing else. Unmute and express. What is internet? Yes.
Sir, internet is a vast network that contacts all computer all over the world.
Good.
Means through internet, the all computer are connected with one to another. That's it.
Good. Good. So the internet, world's most extensive network. In connected means, we discussed at the beginning of this module. Connected means they are having capacity to exchange the data. Clear? They can receive and send. Then only the connection is meaningful. Am I right? बाहर से जुड़े हुए, for example, you have mobile, you have internet, but you have not switched on the internet on your mobile. You are only availing the communication features. That means somebody can call and you can attend this call, or you can respond it. Only this you have. Do you think that's a net? You are in a network? Or somebody else is just keeping switch off their mobile phone? Then whenever I ask a question, beta, the answers are simple. I expect that you people, and I'm expecting from everyone, don't create your representative that somebody else already answered. I'm expecting from each and everyone, those who are attending in the session. Okay. Then, so they have one body or an internet service provider through which we will get connected. We already discussed, it may be your telecom service provider, it may be someone else, GTPL, or some other agency, those who are giving you that connection. And that connection also of a various type. Dial-up is called like through landline connection. Purana time, it's old fashioned, before 2G even. You were having the landline phones, clear, and through which you use the phone, as well as you can use the internet. So these connections called as a dial-up connections. For that time we use the modem, modulator and demodulator, 01, and then waves to 01. Then digital subscriber line, so whether it's DSL, IOFS, or T lines as well, or a T1 or T3, that's a dedicated line from the provider to the person, those who are requiring. Dedicated, no one's in between. So the beauty of it is that it have the highest capacity of transmission, because you are having dedicated line to transfer the data. You are not using the common line or a common route. Then the cable internet connections, I hope few of you may be using it. So cable connections, that's through maybe your cable TV provider. Cable TV provider also same time supply the internet as well through the same cable. That also the one feature. And satellite one. So satellite one, just I already explained, that's maybe you can use direct to home services through the antenna. So you are using the antenna called dish at your roof, direct this dish through the LNB to catch the signals which are you can say shared through the satellite. So it will catch if it is on a particular angle. So it's a direct line, straight lines, right? So if it is in a straight line, it will catch a particular angle in which you need to put your this antenna, and it will start receiving the huge amount of signals or the data. T lines I already explained, it's a general line used for the dedicated line used by the provider to the user. Then internet addressing and architecture. Addressing is like knowing, when as Diane said, it's a network that connects devices all over the world. If you are connecting the devices all over the world, then how you will make or ensure the connections with the uniquely with you only from the world. So if they're willing to connect, obviously you must have your unique address. I'm using the word unique in the world. All right. Then only anybody in the world is capable to connect with, especially you, like in our mobile number. So this is for our purpose, but actual coding is different, am I right? Through which it get connected. So whenever we dial a particular number, it codify into another form and then it will connect. I hope you may be aware about this structuring. One, as we discussed already, the internet protocol IP address, TCP/IP we already discussed. Do you ever seen your own mobile device IP address? Any one of you? In your settings or about phone, have you ever seen the IP address of your own phone? Okay, 3 of them only. Again, very poor percentage. You can go to about your phone and there you will find address, which is the combination through the various dots, right? Which is the combination through the various dots. So it's better we will discuss in detail in the next session, because it will not be possible to finish it in a hurry-burry manner. Those who have not seen it, I request to them, please see or watch it. What is the IP address of your devices? So all the devices, those who are on a network, whether it's your printer, whether it's your Wi-Fi routers, whether it's your laptop or desktop, everything have a unique address, so that, as Diane said, that world device connected, so all the world devices have their unique name, so the other device can easily identify where is the device with whom they want to contact or connect. Okay. Thank you. You can go to your about phone or a status or somewhere else. You can search it. It's not a very tough task. You can easily identify what are those things. Thank you.